Okay, now we're going to do question 7. For question 7, I have two particles, plutonium and lead. And in the given time, they starting with different mass, and in given record time, their amount is calculated. Okay, so question 7, I need to find the half-life of each substance. Okay. For instance, let's do it for plutonium. Okay. So I start with 6,400 plutonium. After 3 minutes, it becomes 3,200. So after another 3 minutes, it's halved again. So the half time of the plutonium 218 is going to be 3 seconds, because every 3 seconds is going to be halved. 3 minutes, okay, according to the table. So the answer will be 3 minutes. Then we look at lead. Okay. I start with 16 gram. After 3 seconds, 3 minutes, I still have 14 point something. So it goes down, 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 goes down here until the 27th minutes, and it's halved. Okay. So what I can imagine is if I wait 27 more minutes, okay, it will be halved again. Okay. So the half time, the time it takes for lead to reduce in half, naturally it's going to be 27 minutes. Okay, for lead 214. Down. Question 7. Question 8. Question 8 asks me how much of each substance will be remain after 30 seconds, 30 minutes. Now let's have a look. So what I can suspect, okay, let me draw another column of the table. When 30 minutes, because the half-life of plutonium 218 is 3 minutes. So after 27 minutes, 3 minutes later, it's going to be halved. Okay, so it's going to be 2.25 gram. So let's write it down. 6.25 gram. Okay, because for every 3 minutes it's halved. Okay. Now for the lead 214, okay, the half-life is 27 minutes. Okay. After 1 cycle of half-life, 3 more minutes, it's going to be something like, I don't know, it's going to be something like 7 point, just make a guess. Okay. If you make a logical guess, say 7.1 gram, okay, you get full mark. Okay, that's how I do it. Okay. So 7.1. Okay. Even you write down something like 6.9 or 6.4, you get a mark. Okay. So if you write down something like 5, you won't get a mark. Just make it sure it's logical. So every 3 minutes is roughly decay by 1. So in here, well, say, so we can make a more accurate guess. So on the 24 minutes, it's 8.64. So 3 minutes later is 8. Okay, so 3 minutes later, it's going to be 7.4, around 7.4. Okay, 7.3 or 7.4. So just give a rough guess. You get the mark. That's it. Okay. Now, mathematically speaking, there's a formula to do, but no, I didn't ask you guys to use the formula. Okay, just do an estimate. Now, let's go on to the next part of question. In the next part of question, here they are. Okay. We need to find the time at which there will be only 4 grams of each element left. Let's go back to the table. Okay. Let's go back to the table. So actually, let's do the working out here. Okay, let me do the working out here. Let's start with polonium 218. The half-life is going to be 3 minutes. Okay. I start with this. Okay. From the previous table, I can say that after 30 minutes, I have 6.25. Okay, now let's stick with table. Okay, sorry. Okay. Initially, at 0 minutes, I have those much. At 27 minutes, I have 12.5 grams. Okay. At 30 minutes, one half-life cycle later, I have 6.25. Okay. Now at 33 minutes, okay, I have 3.125 grams left. Okay. Now we need to find the time that is 4 grams. Okay. Now we can say at 30 minutes we have 6.25, at 33 minutes we have 3.125. So maybe just make a guess. Okay. Maybe just in the middle of 30 to 33 minutes, I should have 4 grams. Okay, just make a guess. If you write down 31 or 32, you get full mark. So I'm going to try 32. Okay, write down 32 minutes. Just do an estimate. Okay. Then what's happened is we have lead here. Okay. So the half-life of lead is going to be 27 minutes. Okay. Previously. So at 0 minutes from the table, at 0 minutes I start with 16 grams of lead. I have 16 grams of lead at 0 minutes. After one half-life, which is 27 minutes, I have 8 grams. Okay. Now, after another half-life, which is 27 plus 27, 54, 27 later, okay, I have a half-life, I have 4 grams left. Okay, so that is what we want. So I need to wait 54 minutes. That's question 9. Now let's go to the last question. It's the last question. Now I want everyone to pay attention with the last question. What type of radiation, okay, is emitted? Okay, let's have a look here. Okay, we have polonium decays to lead. Okay, what type of radiation it is? Now, step 1, write a chemical equation. If you write a chemical equation, you get 1 mark. Okay. Now, polonium is becoming lead, and the numbers in the chemical equation doesn't end up. So it means there must be another element. Okay, so 82 plus a number give me 84. So that number must be 2 because 82 plus 2 give me a 4. That's the only number we have. Well, that's the only number that do that. Okay, so that's atomic number of 2. For the mass number, we have 218 equals to 214 plus a number. So 214 plus a number gave me 218. So this number must be 4 because when I add these two up, I should have 218. 4 and 2, alpha particle. It should be in your notes. Alpha particle has atomic number of 2 and mass number 4. So this must be alpha decay. Okay. If you have the chemical equation, you get 1 mark. If you have the word alpha decay, you get another mark. Down. Okay.